Hi guys, this is Danica Dvorak and my partner is Jordan Stevens. This is homework 18 for Engineering 460 Monte Carlo class. And this prompt is to look at sampling from n of 1, 0, so binary, using the random walk algorithm. So the prompt is, we wish to sample from a density right here, this density function, with a proposal density right here given on support from x minus a to x plus a. And then we're given this acceptance probability. So they're calling this function MCMC, and with iter number of variates given xo. So in this function, our inputs are that xo, so the x minus a, this is xo, is that x, a is the minus a plus a, and then iter is the number of variates. So go through, there's this for loop with an if loop in there. They say to end the do loop. We don't do loops in MATLAB, we just have that as a for loop, and that is actually the end of the function. So given those, they give us kind of these three different scenarios, which we've modeled in MATLAB, and then the last one we get this histogram, so that's what we're going to be looking for. So if we jump over to MATLAB, here's our function that we translated into MATLAB, and you can see we still have those same inputs of xo, a, and iter. We have this for loop with the if loop in here, and we're going to do that plot at the end. So I already ran this, and you can see our notes here. Part 1 has a long burn-in time, but it doesn't seem to have a good representation of normal movement. Part 2, we see that the burn-in time is less than Part 1, and then Part 3, we check to see if it's normal. So I already ran this just to make sure that it would run in time for this video, but you can see this is part 1, all these outputs for the MCMC, and I'm scrolling back up to the very beginning, all the way up. So all this chunk right here is for part 1. It goes down through all the way till we get to 500. So you can see what he's talking about when he says, Jordan, when he says that there's a long burn-in time. It takes us all the way to there to get to the answer. Versus in part 2, we start here, and it is quite long as well. It's definitely very long, but it's not quite as long as part 1. But we do end up getting down to that same answer. And then for part C, this is our histogram. And you can see it looks very similar to the one in the book where it kind of slopes off here at -4, comes up here. It looks like that normal distribution that we're looking for. So that's our homework 18. If you have any questions, you can drop them in the comments on YouTube below. And if you want to scroll back through our code or any of those outputs, you can just pause the video at any time. So I hope that was useful, and thanks for watching.